Okay, good. So you have the videos after the class. So this is the density of the concrete, but sometimes what me personally I do, I add although the good thing about the software, you can see the finishes are there and all of that. But in some cases where you have probably you are using a finishes, you can add this to this, but that's in another case anyway. But this one is quickcivilseries, so we are good to go. All I need to do, I can apply. That's if I am okay with everything that is here. If you look at this down here, you can see there are some other informations here that I can change or I can add. So if you look at this, is geometry telling you the breadth of the beam, the heights of the column. That's the, when you look at the cross section of that column now, it says 230 by 230, and then the height of the column, it will take the height of the building, which is 150. That's coming from the architectural drawing. You can go down and change some other few informations. Now you can see this is based on British standard. So like what Oga was saying about the Euro code, you know, the factor of safety for your dead load is not 1.4. The factor of safety for your live load is not 1.6. Am I right, sir?
For
yes, for Euro code.
Yeah, no. We don't use this. Right?
So this British standard.
Yeah.
This BS.
Yeah.
So you can make reference to your this thing. So if we are very cool with everything that is okay here, I can just click on apply. So once I click on apply, now you can see this is how the window is going to look like. The first thing here you see is the home, where you can create a new project, which we just did. Then you can see open project. If you have existing, you can save this job. You can copy paste, copy floor/drawing page. I'm going to take you through most of this, and then you will see how to navigate. So this is prepare/print. That's when we are done with our entire design. Probably want to print it, we can come here. So this is where we are going to do the major work. On the modeling tab, you can see it has modeling tab, it has basic drawing tools, design and detailing, and the software has a way, they arranged it in a way that you cannot get confused, because the first thing you do in every design is to come up with your general arrangement. When you do your general arrangement, then you can now talk of loading that project structure. When you load that structure, then you can now analyze it, then design it. So the software has a way of arranging them for you so that you don't really get lost. So if you look at this, you will see it has arranged it in a way that you can load the project, you can analyze, then you design, because the design comes last, then the detailing will now come after. So if that is correct, we'll come back to our modeling tab. When we come to this modeling tab, you can see what we have here. We have rectangular panel, we have special panel. That's in a case where you have maybe like a polygon or something. You can have irregular shapes, so you can use this. Reference panel, I'm going to go through this. I will show you in this very class how to make use of this. Panel properties, as the name implies, to see the property of that panel. That's when it comes to the type of panel. Is it a two-edge discontinuous, adjacent edges discontinuous, and all of that. You are going to see how I'm going to demonstrate it here. Insert beam span and all of that. So let's just go straight into it without having to talk too much. So if I click on this rectangular panel, I can just click any point. Now the good thing about the software, you can see these grids, they come in form of a graph. If you look at this here, you know this is your origin, this is 0, this is 0. That is your starting point, and then is actually in an increment of 1,000. So this is 2,000, 3,000, 4,000, 5,000, and all of that. This one is in an increment of 1,000 as well. You can reset it, and reduce it or increase it. You can make it increment up to 2,000, 4,000, 500, like that. So, but I'm going to leave it as it is like this, and I will click on the rectangular panel and I will click here. Now, if you look at this panel very well, you realize that this panel has been created along the x-axis. This is 2,500, right? Along the x-axis. Along the y-axis is actually at 1,000, right? So we can confirm that from here as well. If you come here, you can confirm it. So you can see start point at 2,500 along the x direction. Then along the y direction, we have 1,000. And then here you can see the size of the panel. You can see the width of this panel now is actually 2,500. And then the height of this particular panel is 3,000. So let's assume, although we are still going to import drawing, but let me show you how to come about your model directly from the software as well. So if I click on this panel now, for example, I will come to this reference by panel, or I can probably just right click, and when I right click, I can copy this panel to any direction. Let's say I want to copy selected to the right. You can see it has copied. Let's say I want to also copy another one to the right direction. You can see. Let's say I want to copy this panel down. Copy selected bottom. Good. Copy selected bottom. Okay, now I'm going to use a lot of instances for us so that we can have a more realistic feel of what you can do with the Quick Civil series. Let's say I want to make this a cantilever panel. I can reduce the size of this panel along the x direction. I can reduce it. So if I come here, now I can come to this. Now you can see along the x direction, if you calculate from here to here, now it's stopping at 7,500. That's what it means. That's if you calculate, if you measure from here to here, that's basically what it's telling us here. So, but that's not my concern. Here, I want to reduce this to 600. Let's say we have a 600 cantilever. If you are confused at any point, you can stop me so that I'll check it again. Let's say this one, I also want to have another cantilever. But this time around, I want to make this one 1,200. So I will scroll, and then it's going to be along the height. This height now, I will change it to 1,200, and I'll press enter. So you can see I've been able to come up with a model, with a general arrangement. Now, one good thing about the software is wherever you have an intersection, it assumes it will introduce a column automatically for you. But you may not want that in your design. So you can also remove some of the columns. You can play along with this your model to achieve any kind of model you want to. So now this is what I have here. The next thing I'm going to do is to create new beams/span. Now if I click on it, you can see automatically it's telling us that this is beam 1, this is beam 2, this is beam 3, this is beam 4. If you are used to doing your detailing manually, you agree with me that this is correct. Now this is 1, this is 2, this is 3, this is 4. Now this is a continuous beam, this is single, this is single, like that, and then this is 4. Okay, this is 1, 2, 3, 4, this is 5, 6, 7, 8. But let's say I don't want this beam that is here. What I can do is I can simply highlight it and delete it. I don't want this beam. I just want it to be just a slab cantilever, just the slab only. And see, it's off. Let's say I also want to delete this beam here. Let it just be just the slab. Okay, there is something I needed to do. You are about to delete span 3. Now this is span 1, this is span 2, this is span 3. We have 3 span, continuous beam. I will say yes, and then when I say yes, now it's going to ask me if it should stretch this particular if it should stretch the beam. So this beam, I can tell it no, I don't want it to be stretched. I don't want it to be stretched. I just want it to go. You can see it has gone. Don't worry, you will understand what I did. This one, yes. So this one is wrong. I'm supposed to stretch it. So I can stretch it this way. So you can see it's gone as well. That place is tricky, Abi. We understand? Okay, good. Now, this beam, I don't want to have a column here. Like I said, wherever you have intersection, anywhere you have an intersection, you can see these nodes, node. That means the software.
Sorry, before you go far, this second beam, it's like you clicked on it and you drag.
Yes, I stretch it.
Okay.
Stretch. There is a tool called stretch.
Okay.
If I click on this beam, let's say I click on this beam, you can see stretch. It has a stretch tool. This beam now, this beam, what this is showing us, although it has not introduced the column yet, but the software is already telling us it's going to introduce a column here. It's also going to introduce a column here. But I don't want to have a column here. I also don't want to have a column here. But I just want to have this beam round this slab. I don't know if it is making sense. Okay, good. I will select the beam and I will come down here. Now you can see we have end support, we have start support. So this is our start support, this is our end support. Now it goes like this, from left to right, from here to bottom. So end support, here I can select none. I will come back here. I will select none. So this one is a primary beam. Wait, before I proceed, I hope you understand what is going on. Now, what this is now is, this beam is going to be resting on top of this beam that comes here. It's also going to rest on this that comes here. So, what that means is that this beam has become a secondary beam this beam is now a primary beam. So this beam is going to be acting on this beam and also on this beam if we divide it by 2. Half of it is on this, half is on this. So what that means is that this is reacting on this as a point load. So I will make this now a primary, I will make this beam a primary beam. So I will come here at so this is our start, Abi. This is the end. So at the end is going to be primary beam support. Very important. If you don't do it this way, when you generate your detailing, it won't generate it right. So it's very, very important. So this one as well, at the end, click on this drop down menu, click on beam, primary beam support, and then we are good to go. So if you look at this very well, you realize that this node is a bit looking a bit, there is a little difference, but don't worry, you will appreciate it more when we create floors. You appreciate it more when we create floors. One more thing that we can do is select and come here and specify our reinforcement for each of our structural member. But I think we have already even done that in the beginning, if I'm not mistaken. But if you have not done that, you can come here and check your reinforcement. You can see because this is a panel, you can specify the reinforcement you want to use for your panel. Although when we want to do the design, we'll also have a menu like this that will come up for us to select our reinforcement and the spacing of the reinforcement. But you can also do all of that from here. So like you know, for your slab, mostly customary to use Y12, that's in Nigeria. Then you can do that for all the structural members as well. So for your top bar, you know, this one is for bottom, this is for top, and then I think we have the top distribution bars. So you can do all of that, select, specify the reinforcement. All you need to do is just double click here and you can change the reinforcement. So but we are agreeing that this reinforcement is okay, so we can leave it. When we proceed, you will see how we can correct that as well. But if I click on this panel, one very important thing again that we must always do is the slab boundary. Yes, very important. Now you see this panel by default is telling us it's interior panel, but you know it's not correct. So we will now select our panel edge conditions. Now if you look at this panel very well, I know this place is always very tricky. This is adjacent edge discontinuous. This is two adjacent edge, is discontinuous along here, is also discontinuous along here, but is continuous here, is also continuous here. I don't know if it is making sense. So along here is discontinuous, along here is discontinuous. Aganiza. So if we look at this now, we now have two adjacent edge that are discontinuous. So I will select it. Similarly with this. Now if you look at this panel, if you look from here to here, it's shorter than from here to here, right? So that means we have two short edge discontinuous, we have two long edge continuous. So if I click on that panel, I will come here and I will come back here as well. So we have two short edge discontinuous. So I can use this one. Okay, this is one, where is it? Two short edge discontinuous. So I can either pick this or even pick this, I'm still correct, right? Look at now, along the shorts, discontinuous, long, continuous. So if I pick either this one or this one, I'm still correct. This is too long edge. Oh, it's discontinuous. Oh, I thought it's continuous. Okay, sorry, discontinuous. This is too short edge, discontinuous. Sorry, I thought this is continuous. Okay, so we have too short edge, discontinuous. It's good that we are even understanding it. So if you look at this now, what this panel means is that we have one long edge continuous, three edges discontinuous. Thank God we have smart people. Well, I have tried to explain this thing to some people. It's a lot of work. So if you look at this now, this is three edges discontinuous, one long edge continuous. Good. Okay, good. This one now, we have two long edge that are discontinuous, two short edge are continuous. So that's basically what I do. Yeah, I'll come here. So sorry, that's not it. Here. Then I will select two long edge discontinuous. Good. Then this one now, we are going to have two long edge, no, one long edge continuous, three edges discontinuous. Three edges discontinuous, one long edge continuous. Good. Chicken, we are done. Then another thing again, very important. Each of this panel, you can specify whether it's a two-way or one-way slab. Now, you know, when you divide the long span divided by short span, it will tell you the value. Now, when the value is actually, when you have like 4 divided by 2, you are having 2. What that means is that that panel is actually a two-way slab. So when the value is equal to or greater than 2, that panel is actually, sorry, when it is less than or equal to 2, that panel is actually a two-way slab. But when it is greater than 2, that panel is actually a one-way slab. For example, if we do 4 divided by 1, we are going to have 4. It's greater than 2. If we do 4 divided by 1.5, it's definitely going to be greater than 2. It will be 2 point something. So it's greater than 2. That's a one-way slab. So what we'll do from here is to specify what type of slab is this based on its geometry. If you look at this slab now, is a two-way slab. So two-way and one-way are in the same category, so we'll leave it. So this is also going to be within the same category of two-way or one-way, which I'm also going to leave it. Two-way or one-way, I will leave it at that. Then this one, you know, is a one-way slab. This is 600, and then this height I think is 3 meters. So if you punch from your calculator, let's do it very. If you punch from your calculator, if you punch 3 meters divided by 600, we are going to have 5, so which is greater than 2. So it's a one-way slab, right? So it's one way, and it's also a cantilever. So we can come here manually and tell the software to help us detect and tell this one that is a cantilever slab, or we can use these tools. If we use this tool, we can say detect cantilever slab. So the software will automatically help us to detect those slabs that are cantilever. So this one, similarly, though it's a cantilever, but that's cantilever. So this is a cantilever, this is a cantilever. I want to be sure this thing is no longer there. So I want to be sure that we don't have it as a support. Okay, fine, we are good to go. I will come back to the modeling tab, and then I will click on floor properties. And then I will click on edit floor properties and levels. So if I click on it, now I will specify 2, and I will tell you why. Now the ground floor is already there. The first floor, the software sees it as a story. Then the roof, the software also sees it as a story. So all I need to do now is to copy and create multiple floors. So if I click on that, and I'll click yes, and I'll click yes. Now, don't worry, it's loading in the background. Oh no. Although you see that there is no column here, no column here. There is something I wanted to demonstrate. If you look at this now, you can see this is our, it will tell you make the last floor roof level. Good. So we are good to go. There is one thing I want to do. I want to delete one of these columns, and then because I want to use most of the challenges you most likely face with the software, so I want to delete one of this column and then make this particular beam a primary beam, and then make it this one to be a secondary beam acting on this. Abi? So let's try it. Let's try it. I will come to my views. I hope I've not gone too far, because sometimes if I come to column map, this column, which is this, I will just delete it. And I will come back.
Sorry if I will make a comment there, which is important for
Okay.
most of us as designers.
Okay.
Because oftentimes our challenges are really understanding what the actions are. If you look
Okay.
at the columns,
Okay.
you will see a lot of information coming.
Okay.
Right?
Yes. Yes.
So you can see that you have the marking or the notation for the column, which is the first thing on top. Now the next thing is always an important line for all engineers. Okay, which means that is your load. I hope we understand.
Yes.
So by looking at the layout, it gives you a pictorial information of what really is happening, which of your columns are critical, which ones are not critical. These are how you do inspections, okay, to satisfy yourself as the designer that yes, I'm designing correctly. Because these things are just softwares built by men. But that should always not take away your competence as an engineer. You must learn to know how to inspect your layout and be satisfied that you're okay. When there are instances on site when there's collapse and things like that, these are the things that are investigated. not how beautiful your layout is. They have to interrogate all these information. I hope we're clear.
Yes, sir.
All right.
You are right, sir. Thank you, sir. So, like he has rightly said, although we've not analyzed the design, so most of the information we are getting here are not really accurate. So all this load, you can see everything is the same. But when we do the design, when we come back, you will see that most likely this particular column will be the most critical column, just like he has rightly said. This is going to be the most critical column in this particular building as a whole, because you can see it's carrying this beam here, carrying a beam here, carrying a beam here, and also carrying another beam here, while every other column here, you can see they are just going. When we go deeper, you will see how to play along with this. So if you look at this now, I have been able to delete that particular column that is here. But then this beam, what I'm going to do, I will delete this beam and stretch this beam and make it one. So I will click on delete selected span. Yes. Now I'm going to ask the software to help me stretch. Now you can see stretch span, but if I uncheck it, it won't stretch this one. But you can see everything is ticked. Everything here is checked. So but if I uncheck it, it won't stretch it. So I will leave it checked. Then I will click on yes. So right now I'm only going to have this thing has to bring back that column, which is not what I want. I don't want that. Come to view. We are almost done. The most difficult part of the software is just to model. Once you are done with your model, you are done with the design. Because the design itself is just click, 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 and automatically it just generates everything for you. So you don't want this column. Come back here to okay, fine, good. You can see now it's just one span, no longer two span. So this one now I can come to this beam information. Sorry, I'm looking for support. Okay, good. Now you can see this is our start. Good. You can see it now. You can see it's at primary beam support. So this beam is going to be a support to this particular beam. So it's actually in the right settings, but it's important to always check. So if you don't check it, if it's on column support, that means it's going to automatically introduce a column for you there. And that's not what I want. So I want this particular beam to act on this just for practice purpose. Act on this as a support. Because in reality, maybe there is an opening here. It could be a door or a window, as the case may be. So I think we are done. As far as I'm going, I think we are even done with the entire. The only thing we need to do now is just to come to our design. Now, like the previous versions of Quick Civil series, it doesn't have automatic design. This one has automatic design. I don't have to go through the process of clicking load structure, analyze structure, although it's just a simple click. All I need to do is just to click on automatic design, and I will click on yes. So I will follow the prompt. You can see I will just tell the software start automatic design, and I will tell it yes. I'll click on OK, although it's okay. I'll click yes, click yes, click yes, click yes. Yes, you can see it's just yes. You can take your time to read what it's telling you. It's just basically telling you that to analyze column later, whatever, click analysis structure. Would you like to continue? So if you want to analyze, do you want to continue? I can tell it yes. I want to continue. I want it to analyze the structure for me. So it's just asking you for each of the structural member. When it comes to slab, it will ask you. When it comes to beam, it will ask you, like that. So then there are some menu that will pop up for us where we can do some little settings. So you can see here now, this is for set floor panel reinforcement specification. This is where I was talking about, where you can specify the size of your reinforcement and the spacing of your reinforcement. Now, if we are conversant with our manual design detailing, probably using AutoCAD or so, this is top distribution bar. This is going to be 10. Now, what this one is telling us is the reinforcement that comes back. You know, there is a reinforcement that comes back inside along an external beam. That reinforcement that comes back inside, you know, it will dangle like this. You need to provide a reinforcement at the top. Maybe Oga will share more light on it. You provide a reinforcement at the top. So that's what they call the top distribution bar. Maybe sir, maybe you share more light.
Yeah, that's correct. I think most of them have been to sites.
So that's basically what that is. Me personally, I normally use 1300 self. So so you can set it to minimum 300, maximum 300. Let it not go more than or less than 300. So this one too, you can set it however you want. So you have the top. This is the top bar. That reinforcement that used to be along where you have internal beam. You know, you have a reinforcement at the top that comes. It also dangles. It also has a top distribution bar. That's what we have here. So you can apply changes. You can click on yes. Then this one is beam reinforcement specification. This is for beam, very straightforward. So normally we are advised to use Y10. I don't know, maybe some people still use Y8, but I don't use it for my detailing. So it's customary to use Y10, and then the maximum, minimum, you can set it. You can see the minimum reinforcement Y16. Customary to use Y16 for beam. Minimum also Y16. So all the reinforcement, I will change them to Y16. But since this design is a very small project, I will use my discretion as an engineer and make sure the software doesn't use any other reinforcement aside from Y16. Aside from my links, but all the other reinforcements. So maximum bar numbers, you can also play around with this. Okay, so I'm not going to touch this. You can see here it says modify depth of beam. Then the second option says modify depth of beam if necessary and make floor beam depth uniform if necessary. Now what that means is that, for example, you can see based on the default setting, I specify 225 and then the depth is 450. Now I know from experience that because this beam is acting as a point load on this beam, so this beam is going to be carrying a serious load. It's going to be critical. So it will most likely be the most likely, I said, be the most critical as far as this particular design is concerned. So there is tendency that this particular beam may fail based on the depth. So if that is correct, what the software will do for me if I select this one is it is going to increase the depth of the beam. That's if I select this one. But if I leave it at this one, it is going to modify the beam if necessary, but do so for only the affected beams. So this one is going to modify all the beams. That means if it increases this one to 500, every other beam will be 500. But this one, it can increase this one to 500 and every other beam will be 450 depth. Then this one, I can tell the software, don't modify the depth of the beam, leave it for me like that. Me, I want to probably maybe use my discretion and change the reinforcement that is on this one. However, you are the engineer, it is at you are at liberty to play around with your design. So however we want it, so I can just select any one. But let's say I want it to be here. So I will just click on apply changes and I'll click on yes. Let me see. To size column, the software choose the section automatically. Let's come here first. Now this is another very important aspect. Check this. You see size column section can be lower than the original section if necessary. Don't size, leave the column dimension the way they are. So let's say I don't want this software, please don't change the size of the column, maintain the 225 by 225, so it won't change it. So what that means that in a case where the column fails, for example, like I said, this one, I know from experience that this column will most likely be the most critical column in this building. So let's say for example this column fails. If I leave it on size column, it's going to change the cross section of this column automatically. So but let's say I don't want you to change the column cross section. If it fails, I will find a way to correct that. So it is not going to tamper with it. So then you can just take your time and read through all this, but this is the most important aspect that you should always take note of. And then I'll click on yes, and then it will bring my column menu for me. This here now, I will specify the cross section of my column. So let's say I'm going to leave all these columns just the way they are. So in this building, I don't even have a circular column. I only have a square columns. So but if you have a circular column, you can just specify the diameter of that column. Then minimum bar reinforcement is also customary to use Y16. Some people use Y12, but like we know, when you want to buy your reinforcement, if you use the vernier caliper to check the diameter, it doesn't use to even reach. But most times when you design, in your design, the design may tell you use Y12, but it's customary to use Y16 because that Y12 by a cable. Then minimum number of bars, of course, for normal rectangular or square column, it has to be minimum of 4. Then the links, it will be Y10. Then what else? Then minimum link spacing. So you can also specify the spacing of your links. If you want it to be 2250 or you want it to be 3300, you can play around with it. So but let's say I will leave everything as it is like this here now. Now you can see this is maximum, but I know it cannot go more than this 225 by 225 because this is not a big project. So and then I will click on OK. Then you can see automatically the software has generated just one type of column. In some cases, the software can generate maybe up to 3 or 4 different type of column. Now, what that means is that it can tell you 225 by 225, then the other type could be 225 by maybe 230, Another type will be maybe 225 by 300. So you use your discretion if you want to use two different type or you want to just use one type. So but this building is not a very serious project that we will use different cross section of column. So just one is okay, which is 225 by 225, and then I will just click on it. Then create foundations. Creating foundation, would you like to continue? And I will say yes, and then I will also say yes. I will say yes. However, all this one is just plenty to it. You can take your time and go through it and see what I'm talking about. So this menu will also pop up for me. So let's say the minimum base thickness I want to use is 350, for example. Now, one very important aspect we should take note of is here. Minimum base length for both height and width. This is just telling you the square. So that's the length and the breadth. That's what it means. So I always like to use 1, 2 for most, like a project like this. I know 1, 2 should be okay. And then if you look at length intervals for both height and width. Now this place, what it means is that you are going to be having increment of 100, 100, 100, 100. For example, when you do this design now, and then one of these footing fails. For example, let's say this one, because this is the most critical column as I can see, most likely. Now, let's say this one fails and every other one is actually 1, 2, 1, 2, 1, 2. But this one, that 1, 2 did not actually work. So what do I do? Now, I am telling this software that it should test. The next size of footing it will test is 450, because it is actually going to be in an increment of 100. When it fails for what am I saying? I'm wrong. The base, the base, you know, is 1, 2 now. It will test 1300. When it fails, it will test 1400. So it is going to be in an increment of 100. So if I don't want it to be increment of 100, I can change it. If I want to use increment of 50, I will just type in 50, but I will leave it at 100. So there's every tendency that you may see the software may provide maybe different size of footing. Maybe this one, if it fails. So maybe if this one, if it fails, it will be now 1300, for example, or 1400. It will not provide 1350. So I will click on yes. And I will click on yes. Now, staircase. Usually I don't disturb myself about the staircase because it doesn't generate a detailed drawing. What quickcivilseries does, it will only generate the design, and you know the design is the calculation, not drawing. So it will only generate the design. It won't generate the detailed drawing. So most times I used to just ignore it. But if you want to generate the design, it's the same thing. Number of steps. This one now is from the architectural plan. So you'll be able to know how many steps. This one now is from the architectural plan. You will see it is provided by the architect. Probably based on the height, you know you have riser and all of that. So all those informations are what you fill in here. Now the riser usually is 150. Then the foot, which is the tread, is usually 300. Sometimes it may be 250, but it's usually 1 foot. Then the waist is which is actually the thickness of the staircase itself. It's 150. So if it fails, you can increase the waist. And then the width of the staircase, this one you also get it from the architectural drawing. But this one now, it is you, the engineer, that will determine this one. But this one, it is not you as the engineer that will determine the width of the tread. It is not also you as the engineer that will determine the height of the riser. It's from the architectural drawing. When you check the cross section of the staircase, it is not in your discretion. It is not you that will also specify number of steps. You get it from the architectural drawing as well. What else? Then impose load. Then finishes. This one you can always make reference to your design books. One book I can recommend is Simplified Reinforced Concrete Design by Victor O. Oyenuga. It's very, very important as practicing engineers to get it. It's a practical design book. So main bar diameter Y12, you know, the staircase and the slab, they share a lot of relationship, and you know the staircase is an independent structural member. The load from staircase does not add anything to the building, so it's independent. So you can click on insert. So wait, let me show you something. Let's say I increase this one, just for example. You can take note of the design here. 11.6, are we? 64. You can see the value has changed. The design load has changed. So that's just what I want to demonstrate. So this one is something you can do, that manual calculation you will do. So you can even check this one for yourself. So it's telling us that the deflection check, the check is okay. That means it's okay, it's safe. So that's one way to know if your structural member has failed or it has passed in quickcivilseries. And it's similarly for every other structural member. Who for all this slab, if you come to this menu and go down, you will see this deflection. It will tell you check whether okay or it has failed in quickcivilseries, but I didn't show you that one. So are you sure you want to insert staircase? I will say yes. So I've inserted. Me, I used to just even close it sometimes. So you can see the detailing drawing has been generated in the behind this menu. You can see it. We are seeing it now. I'll click on detailing part. So it's asking us whether it should generate detailing. We can ask it not to. If we say no, it won't generate it. You can see the column cross section. You can see 4Y16. You can see 12Y10. You can see the detailing is superb. I know Oga has used it before, so he knows about it. You can see how the detailing is like very sweet.
Design software, every software has its strengths and weaknesses.
That's right, sir.
So if you are able to know how to use different softwares, you can always integrate. You can design certain sections using one software and another using another separate software. So this gives you distribution bars, while Prota structure does not give you distribution bars. So if you have a way of having them come together, maybe you can define or design your model. I don't know whether this accepts models from Prota structure. I would have said maybe you all your designing your model in there, you can bring some elements here and design, because detailing is easier here from what I'm seeing. You know, that kind of thing. I was just trying to look for whether it can automatically define the panel types by itself like Prota does. And I don't seem to find it, except if maybe I don't know where it is. Because if you have like a large structure and you have to go panel by panel defining the boundary conditions, you know, it will take you ages. You're going to end up with a lot of headache. But Prota does it automatically. So I think he would perhaps throw more light on that eventually.
Okay, just like you have said, he's right. Like me personally, I use a lot of softwares. This my guy here knows. So it's important you have good knowledge of other softwares. What I do mostly, I will generate my reports, design reports from Structure, because Structure is more flexible than quickcivilseries. So you can easily achieve any kind of model. Then the detailing, I can use quickcivilseries to generate the detailing. Then I will export it to AutoCAD. That is why the knowledge of AutoCAD cannot be overemphasized. It's important you know how to use AutoCAD, because even with the fact that this one generates detailing for you, there are some, like the slab cross section now, it won't show you. It won't give you the slab cross section. The foundation layout, as you can see, it will give you the cross section of the foundation, but the layout, it won't show you all those BRC mesh and all those. So it has limitations too. It has limitations. Your slab and beam layout, it won't show you the cross section of that slab and beam layout. So there are some little, if I can start pointing some of the details you won't see here. So that's why it's important to also have the knowledge of. But if you have good knowledge of 2, 3, 4 softwares, you are good to go. So when you have your design, it speeds up your job. So I will click on yes. So this one now is for our reports. So it's just telling us prepare calculation sheets and all of that. So do I want to prepare calculation sheet? Me personally, I don't like using quickcivilseries sheet design report. You can see how the report is in the background. Me, I don't like it. So it's exporting it. It's exporting it. Each one you give it a name. Me, I won't save it. I'll just leave it. Or we want to see the report. It's just a report.
I think that can come.
Okay.
You can always do it yourself.
Okay, yeah.
See how it looks like.
So that's just, you can see a little brief of how it's like. I don't like it. But the software is good, as you can see. Then this one here is just detailed drawing to title block. This is title block, all detailed drawing, title block, current detailed drawing, and all of that. I'm going to show you that when we want to export the drawing. So I will show you all of this. So I'll cancel it for now. I'll cancel it. So all these things, I'm just going to say no. I will show you how to generate that report from here. Prepare/print. Sorry, sir. If I can get water, I would appreciate. Nothing. This is the foundation layout. You can see how it looks like. So this is one of the little aspect of the detailing that I don't really appreciate. You can see the foundation layout. So you can also do some of this editing manually using your AutoCAD. So but let's come to the detailing aspect of this. If you look at if you come to detailing, let me show you floor slab detail. This is the sweetest part of the software that I like. Sweet, you guys see.
Designing slabs is the easiest, but detailing it is
it's very, very complex.
So I think this is a huge plus over Prota.
Exactly. You can see how sweet the so this is the selling points for this software. So you can see that 300 we specify for 300 spacing like that. Thank you, sir. Okay. So another detailing that I know is somehow stressful is beam. So let's see how the beam looks like.
Yeah, the beam is okay.
Yes.
You can see the beam. Very sweet.
And I think one other advantage it has for the way we design here, it takes a straight line, whether there is a column, it takes it as one beam. As against Prota. Prota takes every span as one beam. So you end up with too many beams and you get confused. I think that's one thing.
Yes, that's right.
So I think this is another selling point for this.
Yes, you are right.
Because actually in Europe, we design it span by span actually.
So this is it. We have just 7 beam in the design. I can't even remember. It's a very small. Okay, just 7.
No, you move to the last weight one.
Okay. Okay. So this is it, but I think I made one little mistake because I'm not seeing there is a beam I want it to show as a cantilever. It's not showing that way. What is there? This is it. It's showing. I didn't take it out. Don't worry, there's a way we can play around with it. Let's come back to. It's good that we made the mistakes. Let me show you. Come to floor modeling view. This one here, I'm supposed to delete it. So that's the mistake I did. You can see the stats. You know, this one is the one that has a support, and the support is this beam. So it's good I made the mistake. This one is a beam and is acting as a support for this. You know, we said this is primary, this is also a primary. So this is start, this is also a start. So along the end, we are supposed to have none. So if I select this one now, it's supposed to be none. So support, yes, supposed to be none. Yes, at the end, yes. So this is also supposed to be none. So now we are good to go. So if I can just, all I need to do is just to reanalyze it, redesign it. Let's come back to design. But let's see what floor is this. This is ground floor. Good. Another important thing we need to do is you can see this is roof level. We are supposed to change this one, change current floor panel to roof panels. And I'll click yes. I'll click yes. And I'll apply. You can see automatically this one now is roof. You can see the beam is 225 by 300. 225 by 300, which is okay. So these are some of the things we need to just take note of. And then this one, let me be sure if it is also correct. Good. This is one place I was talking about. You can see deflection check, okay. Deflection check, okay. Okay. So that means that structural member is safe. It's okay. So that's basically what I was trying to talk about the other time. And then this one here, sorry, that's support. Support at the end. You know, that other one was ground. So this one is also none.
Battery gone now.
This one is also none. Good. So we are good to go. So if I am okay with the model, I will just design. And I'll click yes. So this time around, I'm not going to talk anything. I'm just going to keep clicking on yes. You can see all the previous settings are still there. They didn't change. Even when you try to do another design, I think in most cases, all the settings will still be there like this, just like what we set now. Except you want to change them, then you can probably just change them. Okay. Although everything is tampered though, the main thing is we understand the principle behind everything. You know, I tampered with the settings didn't maintain fully, so some of the informations may not come out well. So I'm not going to generate the report. So this is the detailing. So some of the information changed anyway, but the main thing is just get the principle behind the whole thing. So this is the slab detailing. This is the beam. Trying to look for so good. You can see it, what? That cantilever. This was my major concern. I see there are two. Got another one. So we can be confident that our detailing now is okay for our beams. Okay. Then you can see all the structural members are here. Which other one? Pad footing. Let's check pad footing. We can generate for all of them. So let's just generate one. You can see it. Although while we reanalyze it, so the information changed. I didn't specify the information. That's why you're seeing 1000. I didn't change it the second time. That's why. But if I had used that 1 2, it will reflect as 1 2 by 1 2. So this is when you are looking at it from the top. This is now the cross section from side. So what other structural member again? Column, let's see column. All the columns are the same, so you don't have to print all. So what happened is some of the information here too may change. Let's see. Okay, it's still okay. This one is still okay. So that is that. So I think what I have not done so far is just show you how to import your drawing.
Okay, there's one question I want to ask.
Yes, sir.
Is it possible to have the Greek notations show on the model?
No, it's not. You have to manually do that.
Because you see, when you go to the design output for the beams, you see Greek notations showing there, but then it is not showing on the general.
It's not displaying here.
It's not displaying.
Sorry, I want to ask a question. I can see quantities there. What is it meant for? Is it
Yeah,
of
quantity is
concrete
just
or-
as, yes, volume of concrete and all.
Okay, you can extract that.
Yes, we can. All you need to do is to click it. Where is it set?
See
Here.
quantities.
Look at create bar bending schedule.
Schedule, okay.
Just click on it. This is it.
Okay, that's for column.
Bar bending schedule generally. If you can scroll down now, if you scroll down, you see,
Okay.
and you can scroll to the side.
Yes, let me do that.
Yes, to view other members. So similarly, this one now, this is for foundation. This is automatic bar bending schedule. This one is for concrete.
Volume.
All you need to do is just click. The software is click.
But I think on Prota you have that of concrete and formwork. This one is just concrete.
Prota is, you can Prota is more wider than this Quickcivil series and more flexible than Quickcivil series. So this is
terms
just
of detailing as well.
detailing is the selling point of the software.
Yeah.
The detailing is the selling point. That's what makes it great. Because so far, I don't know, I stand to be corrected. I don't think there's any software that can give you any detailing that we in Nigeria will appreciate more than Quickcivil series. For now. So that is that. Then if you are done with everything, you can export your drawings. Supposed to allow me export all. I've never really encountered. Let me pause the record. While we were doing automatic design, I skipped a step. I skipped something while I was clicking those no. So that was why. But you can see this is the foundation layout. This is the footing. This is foundation. This is cross section of your footing. You can see that is because while I was generating the detailing, I selected just one footing. That was why. The column too, I selected just one column. And literally, we are having almost the same column in all the entire. So you don't have to generate all those columns. They are going to be very unnecessary. And then you can see here, this is the slab and beam layout. This is panel 1, panel 2, and that. So here we have the panel 3. You know, it's a cantilever here. That is what you have here. You know, it's a small panel. This is 4, and then this is 5. So this is the beam details, and then this is slab details. Then this is the roof beam layout, if I'm not mistaken. Yeah, that's it. And then this is the roof beam details, and then every other one is the quantities, you know, and the reports. This is the bending schedule. So you can just take your time and go through it till the end. So this is in summary how to come about your design using quickcivilseries.
So I will ask a question. Go back to the software.
Okay.
Okay, so from here,
Okay.
I want to go back to my role model.
Okay. You will come to view,
Okay.
then come to active view. You see there is like a triangle indicating it's a drop down menu. You click on it. You click on floor modeling view,
Okay.
and it brings you here. I don't think there's anything I need to show you in quickcivilseries again. It's true. I don't think there's anything I need to show you again.
Yeah, maybe
Okay, let me show you Sketchpad. Very important.
then
Let me sketch.
Then how to import.
Import. Okay,
Yes.
yes, that's true. That's true.
Just
Just come to an end.
So what can I show you?
Simple software.
I don't know, what can I show you again? I don't even know them. So, but let's catch this beam on our Sketchpad. Yeah, I don't usually use it like that. But let's see if we can take it to our Sketchpad. Where? Sketch? That's stretch. That's stretch. This sketch pad you can just view the bending moments, the shear force diagram, and all of that. Yes, it shows you. There is an information I'm looking for. It's not showing me. But it's usually very useful for maybe you want to see how the slab and beam layouts, and sorry, how the what do you call it, the bending moment and the shear force. Yes, that's basically what that sketch pad is all about. It's nothing serious. Change beam properties. I don't know why it's not. I don't remember. I don't usually use that tool, but no, I'll check it. I'll show you. It's not too important anyway, but it's good you know how to view it. That's literally all what it's all about. But let me quickly show you how to prepare your drawing for this thing. I'm still going to show you this one. I'm just, me, I use a lot of software, so I use a lot of software, so sometimes I used to get a little bit confused. So let's save this work. Save as Dauda or propose. Let's leave it like this. Then let's come to, there is an AutoCAD file I always like to use. Auto file. No, I can't find it. Okay, what we'll do, we can quickly just do a simple sketch. Where is the retaining wall? So it looks complex. Okay, let's just do something very simple. Let's say we have into auto mode. So let's have something like this. Sorry, we'll soon finish. Okay. So I'll bring it out like a simple thing. So let's assume this is what the architect gives to us. So I will use this to just match some areas. So I can simply trim all this part, but let me just assume it's perfect like this. For example, now if I try to extend, normally you will have, let me extend all these grids out. Okay, fine. Then I'm going to assume here to be my staircase area. I'll assume here to be my staircase area. Then here it's maybe like a room. Then here it's, let's say, a cantilever. So if that is correct, So let's have it this way. Now, if this is what we have, I'll delete this one, delete this one, delete this one. Assuming we have done our general arrangement already. So I will copy this and put it in a different window. No need for this. Let me just use here. I'll paste it here. So this is our general arrangement, for example. Now, you know, normally if you are using proto structure, you can simply just put your normal shaded columns like this, where you have your column points like this. But in Quickcivil series, it will not recognize it. It won't recognize it. Yes. So the first thing I'm going to do is I will take out all this line, all these other extra lines. Quickcivil series won't recognize them.
As the walls.
Yes. So I need to delete them. I will have to highlight all of them and delete them. So I will just select them and delete. And I will delete them. And then the next thing I need to do, let's say the whole of this is staircase area, for example. This one, I'm going to take it to this place. Don't allow it to intersect. And don't allow it exceed a line. Quickcivil series will interpret it as a beam. Quickcivil series will interpret this as a beam, interpret this as a beam, not as a grid. So you have to use your fillet. Make sure it's actually very, very clean like this. No any single extension. It should not extend at all. So that's why use fillet. You should use fillet. Use fillet. Use fillet. And then you can also use trim. And you trim, 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 trim this, trim this. This is how Quickcivil series will interpret it. So you can see what I did is just the grid lines that I left, but the wall itself I removed them. So if you come to your Quickcivil series, let's create a new project. Yes. Apply. Let's say everything is okay, and then I will come to this file and I will click on import DXF floor layout. Now take your time and read this thing. You will see it says this operation will import AutoCAD floor. You must take note that wherever you are supposed to have a column, you use cycle to represent it. Now the diameter of the cycle does not matter. So you can see this operation will import AutoCAD DXF floor layout into the current floor. Before you continue, it is important that you understand how the software reads your DXF file. Lines are read as beam spans. So make sure the only lines in the DXFs are beam spans. That's number 2, Abi. No, number 1. Circles are read as columns. Column level. So make sure the only circle in the DXF are column points. The columns created will be below the current floor, below the slab and beam, and below the roof beam. If floors is roof level, the radius of the circle is not important. Rectangles are read as panels. So make sure the only rectangle in the DXLs are panel positions. Polygons are represented as polylines, as polygons, yes, or polylines. So make sure the only polylines or polygons in the DXLs are polygons. Please note that each DXL file represents a floor and not multiple floors. Please note the action will delete all the current elements in the current floor. Are you sure you want to do this? And I will say yes. Now, I know the plenty torrentry. I'm going to summarize it in the detailed drawing. Now, let's come back to it. To the AutoCAD file. And come back here. Now, what it means is that Protas quick civil series will see this as a panel. We'll also see this as a panel, and we see the whole of this as also a panel. That's just basically what the software is telling us. And if I try to introduce a cycle at this point, let's say I have a column here. Now, even if I introduce another different diameter of cycle, it doesn't matter. It doesn't matter the diameter of the cycle. It will see just a cycle. It will represent it as a column. So I can just copy one of the cycle. So let's say these are our column positions, for example. All I need to do now is to export, save this drawing, very important. Right click, save as. If your AutoCAD is not from 216 or so, it may not show like this, I don't know. I think so. You can just simply come to your home, you will see save. But if you come here now, make sure you save it as DXF. It doesn't matter the version of DXF. So me, I always like to just use 2007, but it's not a rule. So I can save it as, let's say, quick or DWG or quick DWG. However, that's just how I want to save this. So I can just save as DXF, and then I will close it. Save in AutoCAD 2018 version? No. So I'm leaving it as just DXF. So I can come to my quick civil series, and then this is the file, and I will click on open, and I will click on yes. Now apply. That is that. Shikena. And then you go through this process we did before. That's all. Insert, yes. So to insert panel now, just come to modeling, click on rectangular panel, and we select. So this is a staircase area, but I'm still going to use that rectangle. I'll show you one thing I didn't show you before. So the only difference here now is I'll click this panel and I'll specify this that this one is a staircase. I think it should be under here. So staircase board. That's all. Then every other thing is the same thing. Abi? That's all. Every other thing is the same thing. But if you want me to, do you want me to take the design?
No.
Okay.
Maybe one other thing is, Katuba is using one can still design.
I haven't told you, but it's not even. I won't recommend it. I won't even recommend it for still. Yes, yeah. Except maybe the version 10 year better. Quickcivilseries has version 10 now.
But I think there's 5 or 7.
Sir?
It's not on their page.
Okay, it's some para say that last of year I think it's releasing Nash. Yes. No, it's on sale. If you go to their website, Zaka gan little tutorials that say I can she want she completely the interface Maya change. They made it more flexible, just like the way interface now Supro Tasiki. So it's more flexible. You can zoom. You know this one now you can't zoom, but
Yeah.
That's just what I need.
But you can.
you can only scale. Yes,
There is a provision for scale.
that's not zoom. It's just scale.
With your mouse now,
You can't zoom. You can't zoom in or out. You can only scale. So it's entirely different. You see this scale now? I can just change. Once I click, you can see it has become very tiny. If I come here 150, this is the only way you can make it bigger. So if you select any of this scale now, you can make it.
And since it's changing the rule,
Is that?
as you change the scale, it's also changing in that.
Definitely. It will. This is just a way of zooming it. Except this is just the only way you can. But in the version 10, is better. You can.
You can zoom in.
Yes, you can zoom in on it. You can zoom in on it. So this is just the only way you can manipulate it. You can't really do any this thing. This is another way. You can see it has, but it's not as flexible as.
You want the mouse.
It's not. This one now. This one has a specific zoom scale that it will go. You are not at liberty to zoom it to any this thing you want. So I'll take it to 100. Take it up. Then I'll take it down. So I always like to leave it at 100. Which other thing, Kumar? I think it's just that sketch part something that I didn't show you. But it's not, it has nothing to do with the design. It has nothing to do with the design. Always say drawing how the bending moment, shear force, you can even confirm it by doing your calculation manually to see what is giving you. It's very interesting. It's very interesting. Oh, I'll figure it out before I leave. I have forgotten it. So this is basically how to come about your design using quickcivilseries. You
So
have
now,
questions?
the ones we've done now, we've been able to successfully include panels on rectangular shape slabs. What if you have irregular shape?
That's where this one comes in.
Then you select the option for the
Yes.
polygon.
Special panels.
Okay.
Special panels.
So how do you select the boundaries inside? That's my question.
How to select your boundary?
Yeah.
No, you know, when you are importing your drawing, it tells you it sees polylines as polygons. You remember when we were trying to import, see, this is what it says. Look at it. Polygons are represented as polygons or polyline. So make sure that only polygons or polylines in the DXF are polygon. Please note that DXF file represents at floor this. Okay, sorry, this is not where. Rectangular panels.
Rectangles are
Rectangles, yes. Panel positions. Polygons are. So if you want to represent an irregular shape, which you can also achieve here. You can also achieve it from here. You know, I started my first